And the last standard that has found its way in terms of release was last year. What we call we call it Jpeg XL. Again, XL doesn't stand for extra large. It stands for extension for long term. And the goal of Jpeg XL is really to really replace JPEG. JPEG is now over 30 years old, and it's really time for it to be replaced. But it has been very difficult. JPEG committee itself tried, and many others tried. They haven't been successful. Now, Jpeg XL has been designed in such a way that actually this transition makes sense. There is enough incentive for that. I don't want to go into all of the details because that's not the goal of this talk, to go in details. But let me tell you a few things that Jpeg XL has that no other standard offers. One of them is that because this JPEG 1 ecosystem is so strong, you must have a path of transition from the most legacy systems to most recent systems, which means that Jpeg XL and JPEG 1 should coexist for years. How do you do that? You do that by doing a lossless, completely reversible transcoding. So Jpeg XL has been designed in such a way that you can actually take a JPEG image, compress it, or transcode it rather in this case, to Jpeg XL, sometimes get between 20% to even half the size, which is significant if you have many images, in a numerically lossless way. And you think about it, the reason HIF or AVIF in future will have never any penetration the way they expect to have is because often from user point of view, if you have an image of a wedding or children being born, etc., you don't want to destroy the quality. And the transcoding by going to JPEG, from JPEG to any of these other standards is actually lossy, which means that you cannot guarantee you would not have losses that won't be visible. In Jpeg XL, you guarantee it won't be because it's numerically the same. And at the same time, you get, the architecture here again, I would call it second generation architecture. So it's again based on DCT and transform and pre-processing, post-processing, but a little bit different in terms of general architecture. So it's not the clean architecture that I showed you for JPEG, Jpeg XR, and Jpeg 2000. It's a little bit more advanced. For example, the DCT is variable size. It also, because the reason I told you, it can actually get a JPEG as an input and not a RAW as an input. And it can do, by the way, both lossless and lossy. And in fact, it has been shown by outside tests, have nothing to do with JPEG committee's tests, that it is actually today, in terms of lossless compression, way above anything else that is around. Now, you would say, what about complexity? Well, I can show you in terms of complexity. It is actually very, very, very similar to JPEG. It's almost like having the lunch and eat it too, free lunch. If you compare it to one of the fast implementation, actually the fastest implementation in software that is accessible publicly, which is called Turbo JPEG. Jpeg XL encoder is slightly faster. It's unbelievable. On the same hardware or software, it's slightly faster. In decoding is slightly slower, but really in few percent. Compare that to HEIF, right? It's just completely different, right? You're talking about at least 10 times more complex in decoding and around 15 to 50 times more complex for encoding. And in terms of quality, actually the results of JPEG XL at very high quality are very competitive with HGIF. In fact, in many cases, textures like the skin or textures that are very hard to reproduce, usually in a compressed environment, are pretty good.